Hi there, I'm Nathan Hekman and I'm a student at the University of Michigan-Dearborn. And I'm in a class, System Design and Microcontrollers. And for our first project, we were assigned a task to build a robot that one of its main functions is to follow a white line on a black surface. So in order to do this, we had to implement several parts. One of these is the sensors that we use to actually detect the white. So there's two main parts here. There's one that emits UV light that this circuit is mainly involved in, and another part that collects the light and senses whether there is a reflection of the UV light. And so if there is a white surface, meaning it's on the line, and there's a reflection, then this transistor is going to be powered to the base so that current is able to flow to ground. And here is where our PIC microcontroller is, so it will sense a low or ground, meaning that there is a white line. If there's not a line and there's no light that's being reflected, it's a black surface, then this is not going to be powered, and so it's going to be an open circuit here, essentially. So it's going to sense a high, or 5 volts approximately, to the PIC microcontroller.
Hello, my name is Sergio, and now that you know how the sensors work, here we're going to go through what to do when the sensor detects white or not white. So when all three sensors detect a 0, which is not white, what do we want to do? We want the robot to stop. But like for example, if they all detect a 1, which is white, we want the robot to move forward. Similarly, through every case, we determine what the robot should do. So through code, the way this works is that if it's on tape, the sensor is going to be 0, which is logic low. But if it's off tape, it's not going to be 0. So here, the pound defines like port B4, RC4. That's going to correspond to the left sensor. And we did that also for the right and the center sensor.
Hi, my name is Comben, and I'm going to explain the blood and guts hardware of our line-following robot. Now, I know this looks kind of complicated, but it's actually a very simple input-output logic sort of deal. So we use our microcontroller, the PIC16F690, as kind of a to determine what to tell the motors. So we have our inputs of the sensors at these 3 pins. And what this does is it outputs a logic of 0 or 5 volts to this, our motor driver, and you can see the part number here. So you receive 2 inputs for the forward and back, the plus and minus parts of our motors. And what you do with that, the primary purpose of this is to just take a voltage input and change it to possibly a different voltage output. So maybe you want to run your motor at 9 volts instead of 5 volts like we want to. So it takes our inputs and then it outputs it to the motor, telling it to go forward or backward. So right now, this is hooked up to show our right motor, and the left motor is very similar to it. So in order to do that with 9 volts or any other thing, we have this, we have a voltage regulator, the LM7805, and this just allows us to take our 9 volts, which we want to drive the motors, and also get the 5 volts, which we need to power our ICs. Okay, so now that we've talked your ear off about all the technicals of this project, this is actually the finished project, and we've created a little video with this little guy in it. Hope you enjoy it.